Welcome back to our channel. For new subscribers, thank you very much for watching our videos. For the returning subscribers, thank you for your continuous encouragement. Please do well to hit the subscribe button to subscribe, as well as clicking on the bell icon. Please do not forget to like, comment, and of course share the video. Now, in today's class, we're going to be talking about organic chemistry. You might want to ask yourself, what is organic chemistry? It's very simple. Organic chemistry is organic chemistry is the study of the chemistry of carbon. Now, over the years, this particular course or this particular topic has proven to be difficult to most students in the high school, partly because of the fact that they didn't really have a good teacher to break this topic down for them. Okay, so in this particular video, I'll be explaining why it is called organic chemistry. Proceeding from here, we'll look at organic compounds, the central atoms in organic compounds, and why we normally use that particular atoms or that particular atom as a central atom, and of course, the first organic compound that actually was synthesized in the laboratory. Okay, since we've actually seen that organic chemistry is a study of the chemistry of carbons, most of the times you can add any derivatives. Now let's look at what is organic compound and why is compound, or why are compounds referred to as organic compounds? Is it really that all compounds are organic? Okay, now what makes a compound organic? Very simple question. Okay, now a compound is said to be organic if it contains carbon, at least carbon and hydrogen. That simply means that for any compound to be termed organic, that compound must contain carbon covalently bonded to hydrogen. It therefore means that what if I have CO2? CO2 is not organic compound. Yes, it has a carbon, but it does not have hydrogen. What if I have CO3? This is not organic compound. Okay, what if I have CH4? Yes, this contains carbon and hydrogen. The type of organic compounds that contain only carbon and hydrogen are referred to as hydrocarbons. So this particular compound is referred to as hydrocarbon. What if in a case where it contains carbon, hydrogen, and oxygen? This is actually an organic compound, but it is not referred to as a hydrocarbon. Okay, so in summary, for any compound to be called organic, it must possess at least carbon and hydrogen. Okay, so maybe somebody asks you, why is it that, or why do we call this particular compound organic compound? It's very simple, because it contains carbon and hydrogen at least, right? Now, those compounds that contains only carbon and hydrogen are referred to as hydrocarbons. But remember that all hydrocarbons are organic compounds, but not all organic compounds are hydrocarbons. Okay? Now, so what if you're asked to define organic compound? It's very simple. You can simply say, okay, let's define what is organic compound. Organic compound. Organic compounds are compounds that contains carbon and hydrogen only, or compounds that contains, in addition to C and H, in addition to carbon, They are compound that contains, in addition to C and H, other atoms such as oxygen, nitrogen, sulfur, etc. Most of the time, these atoms are referred to as heteroatoms because they are somewhat different from carbon and hydrogen. Okay, so since we've actually seen what organic chemistry is, the study of the chemistry of carbon, and of course we've seen what organic compound is and what actually makes up an organic compound. Okay, now the next thing we're going to be looking at is the central atom used in organic compounds. So we say central atom. So we have central atom in organic compounds. Okay, now please take note that the central atom in organic compounds, in all organic compounds, is carbon. Now, why is carbon always referred to as the central atom in all organic compounds? Now, this is actually because of the uniqueness of carbon. All right, carbon actually possesses this uniqueness, which we call catenation. All right, so all organic compounds, the ones you can remember and the ones you can't really remember, they all have carbon as their central atom. Now, why is it not any other atom? Why carbon? I said the reason because carbon has this uniqueness that is called catenation. And what is catenation? It is the ability of carbon to form a stable long chain with itself and atoms of other elements. So say catenation is the ability of carbon to form a stable long chain with itself and atoms of other elements. Okay, now what are we referring to here? Now this is what I simply mean. For example, you will notice that carbon can form C20. That is C bonded to C, bonded to C, bonded to C, bonded to C, and so on and so forth. Right? Now you notice that these bonds here, these chains, are very stable and very strong. Right? It is only carbon that can actually exhibit this property. The only element that comes close to carbon but not as unique as carbon is silicon. Silicon is actually in the same group of the periodic table with carbon, is below carbon. So, and if you could recall, elements in the same group of periodic table, they possess similar properties or similar characteristics. Okay, so silicon belongs to the same group as carbon. So silicon to some extent can form a chain, but not as long as carbon and not as stable as carbon. So the major reason why carbon can actually act as a central atom in all organic compounds is simply because of its uniqueness known as catenation. And what is catenation? The ability of carbon to form a stable long chain with itself and atoms of other elements. Okay? Alright, so since we're actually done with that, let's now look at the next one here. The first organic compound. First organic compound to be synthesized. All right, as long as the earth exists, organic compounds of course already existed. So we have natural occurring organic compounds. Okay, so what we are looking at is the first one that was synthesized in the lab. Remember, this was not the first organic compound that was known, right? As long as they were the composition of humans on the earth. All right, so definitely they decompose and they give rise to different kinds of compounds. But the very first one that was synthesized from an inorganic substance is urea. Okay, so we say the first organic compound that was synthesized from an inorganic compound is urea. Okay, so urea was not the first organic compound on the surface of the earth, no, but urea was the first organic compound that was synthesized in the laboratory using an inorganic compound. And that inorganic compound is ammonium cyanate. So we have ammonium cyanate has a formula of this. This is ammonium cyanate. So when you heat this ammonium cyanate, it's going to give rise to urea. Alright, and if you could recall, based on what I gave us earlier, okay, now you realize that this is an organic compound. Okay, this is an organic compound. Alright, so the question goes as follows. If you look at the brief history of organic chemistry, the introductory part rather, the study of chemistry of carbon. Alright, organic compounds are compounds that contains carbon, hydrogen bonded together only or bonded with any other atom such as oxygen, nitrogen, sulfur, and the rest of them. Now we actually went ahead to also discuss the atom that is always acting as a central atom in all organic compounds, and that atom is carbon. Why is it so? Because of the uniqueness of carbon known as catenation. Alright, now we proceeded to looking at the first organic compound to be synthesized in the laboratory. Please take note, urea was not the first organic compound that existed, right? Urea was synthesized in the lab. Okay, so take note of that. So that is that for this introductory part of organic compound. Please like and subscribe our video, and do not forget to subscribe to our channel, because this channel will be informing you about organic chemistry, from the history to the reactions and to the different compounds, and even how to name organic compounds. All right, so please click on the bell icon so that you'll be getting subsequent notification. All right, see you in the next video. Please do not forget to actually tell us what you think about the video. Thank you very much.